Okay, so I have question 169, and it asks to find the antiderivative of functions, and our first function is sine of x. And the antiderivative of sine of x is negative cosine of x plus c. And it's negative cosine because you can think of it simply as what, so the derivative of negative cosine would give us sine. So that would be so negative cosine would be the antiderivative of sine. And you have to add c because you do not know if there was a constant. And obviously the derivative of constants is 0. And since we do not know if there was one, you have to keep c in place of it. The next function is 2 over x plus 3 cubed, and to change it so we can actually find the antiderivative, you have to bring the denominator up, and that's you could do that simply by making the exponent negative. And to find the antiderivative, you add 1 to the exponent and divide the function by your new exponent. So our new exponent would be negative 2, and you divide the function by negative 2, and you end up with negative x plus 3 to the negative 2 plus c, again because we don't know if there was a constant. The next function is secant squared x, and the antiderivative of secant squared is tangent x plus c, and the same thing, you can do the derivative of tangent is equal to secant squared x, and the c because you do not know if there was a constant there before. And the last function is 3 over x cubed plus 2 over x to the 4th, and you do the same thing to take the denominator, to move the denominator up, you make the exponent negative, you add 1 to your exponents, so negative 3 plus 1 is negative 2, negative 4 plus 1 is negative 3, then you divide your entire function by your new exponent, so you divide 3x by negative 2, and you divide 2 by negative 3, and you end up with negative 3 halves x to the negative 2 plus negative 2/3 x to the negative 3 plus c in place of the constant that might have been there.